This comes from the Storm Prediction Center, and it basically takes our convection-allowing models, our CAMs, like the HRRR, the NAM 3 kilometer, and treats them as an ensemble. So instead of looking at just one single convection-allowing model run, which has its issues in itself, it treats them as an ensemble. So it's basically averaging out all of the outputs from the different convection-allowing models and giving us an output that is the average of those. So what that can do is it takes out wonky runs or runs that might be out to lunch from a specific convection-allowing model and averages them all out, so we can get a little bit of a better picture overall of how the models are handling the overall environment. So this is the HREF interface, and it's got a bunch of different tools on the top here. One thing that's cool about it is it spits out SPC-esque guidance for hail, wind, and tornado probabilities. So if we clicked on tornado probabilities, this is basically the 4-hour neighborhood probability of a tornado. So the probability of a tornado within the last 4 hours leading up to the time of interest. We go forward, and then you can see it spits out those SPC-esque probabilities, and we can even zoom in to different sectors as well to give us a closer in view. So that's one thing that's very cool about it. You can get that for hail and wind as well. It also goes through all of our different products that we use when forecasting. So, for example, the 500 millibar height and wind, the 700 millibar height and wind, surface temperature and surface dew point, and sea level pressure, etc. So, once again, this is taking all of our CAMs. For example, this product is the 500 millibar wind, and it's taking all of the output at the 500 millibar level from all of our CAMs and averaging them together. So this is an average of all of our convection-allowing models' 500 millibar output. And I'll zoom back out to the continental US sector here. So all you do is just arrow through, and it gives you this nice graphic with a really easy to read color scale that is the average of all of our outputs. It's a really good tool to use instead of just focusing on one particular convection-allowing model run. It allows us to treat them all as a whole, and because we're averaging them out, it takes out some of the wonkiness that individual CAM runs can give us.
The Chaser Academy is our premium subscription, and it's the best deal in storm chasing. Link in the description.
It also has products for severe weather, so CAPE, storm relative helicity, winter weather stuff, fire weather stuff, precipitation, so quantitative precipitation forecasts. It can go out, and keep in mind that this is short range guidance. These are CAMs, so they only go out maybe 24 to 48 hours in advance at most. But we can go through and look at our quantitative precipitation forecasts over a given time period. This is the 1 hour forecast and stuff like that. One of my favorite tools to use is we go under storm attributes and scroll down to where it says updraft helicity and go to the 4-hour min-max updraft helicity 2 to 5 kilometers, and we go to max. This is a really good tool to use because, as we know, updraft helicity is basically the model's way of outputting whether or not a storm is rotating. So basically it tells us if the model is projecting supercells. But this gives us a nice probability of updraft helicity streaks in the 2 to 5 kilometer layer meeting a certain threshold. So in just boiling this all down, it basically tells us the probability of storms that the model is outputting to have robust updraft helicity, and therefore the probability that storms are robust supercells. And again, it's probabilistic. This is not one run that just gives you one output of the simulated reflectivity on radar. It gives you a probability. So for example here, if we zoom in, and this is valid, this is a 4-hour max, so from the 4 hours leading up to 23Z, so 6 p.m. Central Daylight Time, it's giving us probabilities for robust updraft helicity. For example, in this area, the probability of robust updraft helicity exceeding that threshold that this model uses is 50%. So in this bullseye right there, that is where the ensemble convection-allowing model system here, the HREF, is spitting out the highest probabilities of robust rotating supercell thunderstorms. Out here we have a 30% contour as well, 10% contour. So this is a really good tool to show you perhaps where the best chances among all the models are for robust supercells. Now, it doesn't tell us anything about the hazards that those might produce. That is up to us to figure out from the environment. But overall, it's a nice, really good tool to use when you're forecasting to pinpoint where the best chances for supercells may be. And if you did want to take a look at all of the individual convection allowing models, we can go under Member Viewer, select Members under Reflectivity, and we have an output of all of our most important cams, the HRRR, the NSSL WARF, the WARF ARW, the FV3, and the NAM 3 kilometer. And we can actually just thumb through them as we would on a typical model site. So you can go forward, see the actual HRRR output, and then if you stop on a certain time, you can go over and change and hover over a different model, and it shows you the output for that model at that specific time. So it's really easy to compare and contrast the model output from each of these models because of this function that lets you stick on the same hour and go from run to run. You can also go back 6 hours and 12 hours, the past 6 hour HRRR, in the past 12 hour for the other cams, because they only come out at 0Z and 12Z. But the HRRR comes out, of course, every hour. So you can actually go back and compare several runs ago, or at least one run ago from these models to see how the model has evolved over time. For example, the current NSSL WARF valid at 22Z has this output, whereas the NSSL WARF from 12 hours ago, the 0Z run from yesterday evening, showed this. So you can compare and contrast within an individual model the runs of that model, or you can compare from model to model at a certain time, which is a really nice way to, again, not rely on just one particular convection allowing model for our forecast, but compare and contrast among different models, which is the crux of good forecasting.
Remember to check out those links in the description below, and then watch another video.